I'm going to speak to you about challenging behaviour, and I want to develop an argument throughout the presentation that some of the models we've had of challenging behaviour that have focused almost exclusively on the environment may to some extent be incomplete, and we may want to consider individual characteristics. So that's the argument I'll be developing with you over the next 40 minutes or so. We know that in people with severe intellectual disability we will see problem behaviours such as aggression, self-injury and so on that are a significant, they have a significant impact on people's quality of life and therefore are of some clinical importance. We know that these behaviours will be shown by about 30 to 40% of people with severe intellectual disability, and also that there are some individual characteristics that clearly associate with these behaviours, such as a greater degree of intellectual disability and some genetic disorders, for example, an area that I'm going to focus on. Recently, we've seen longer-term follow-up studies of self-injury and aggression, and these are sobering in that we do see, for example, if we meet someone with severe intellectual disability showing self-injury now, and we meet them in 20 years' time, they've got an 80% chance, if you like, of still showing the behaviour. These behaviours are very, very persistent. The human and economic costs are well documented, and I think it's true to say that the economic costs will be significantly underestimated. There are a lot of those hidden human and economic costs. And finally, in the UK at least, we lack appropriate intervention. The studies we conducted in the late 80s showed that only approximately 2% of people might be receiving psychological intervention. And studies we conducted within the last couple of years in Birmingham, a large city in the UK, the figures are not dissimilar. So we're not moving ahead very rapidly. If I can leave you with one figure that I want you to remember from this overview, it's this, that there's 84% persistence over a period of around 20 years for behaviours like self-injury in people with an intellectual disability. So the models that we have are primarily located in the environment, and in addressing these and suggesting we need a rebalance in these models, I'm not suggesting that these models are not robust, that the empirical evidence is not robust. It is. But I want to suggest that we need to integrate this a bit more with person characteristics. But let me just summarise that broad environmental model. So if we take a behaviour like self-injurious behaviour, there's well-documented evidence that when these behaviours occur, they may be followed, for example, by attention from a teacher, carer, and this may be reinforcing for the child, making the behaviour more likely to occur in the future, leading again to a presentation of a reward, making the behaviour more likely to occur again. There's very good evidence for this, and I won't recap that evidence, but we know that if this cycle is operative in young children who've just started self-injuring, then the probability that they will self-injure 2 years later is significantly raised. We can locate that model within a broader social context, and what we tend to argue is that this model places the emphasis on a response by people in the child's immediate environment. And this will be influenced, it is argued, by carer characteristics, for example, emotional variables, stress, some cognitive variables, the attributions a carer may have about those behaviours, and these might be influenced by the level of support that carers receive, in turn influenced by broader social, environmental resources, until we come to a very broad level of intervention. I know Eric Emerson will have covered these sorts of arguments and the importance of these influences on carers' immediate ability, if you like, to support people with an intellectual disability achieve the best possible quality of life and intervene with things like challenging behaviour. I want to suggest that those models may not be a complete account of challenging behaviour, nor do they aspire to be, I think. So we know that we may see behavioural correlates, individual characteristics that associate to challenging behaviour, such as diagnosis, such as the presence of repetitive behaviour and restricted interest, impulsivity. And we know that cause of intellectual disability is associated with the behavioural presentation. Equally, if we look at the results of experimental functional analysis, these do not always show that manipulating the environment can change the behaviour. And we do have a growing database on intervention failure. That is, when we manipulate the environment in a way we think is favourable, we may not always be successful. And this body of evidence suggests that this account may be incomplete. And I want to suggest to you that if we do not rebalance the causal model with these individual characteristics, we may minimise potentially important individual and group difference. And a secondary argument, and you can judge whether or not I'm able to make this to you, is that this in turn might deny facets of the lived experience of people with an intellectual disability that are important. So that's where we're going. I can give you the most obvious example of this, a person characteristic that is important in the genesis of challenging behaviour, by arguing that the behaviour in that operant learning model is actually perfectly adaptive. It's very powerful in achieving aims, if you like. So when we run that operant learning model, this is associated with people who would show a restricted repertoire of adaptive behaviour. In other words, not having other behaviours that might influence their environment. They may also have impaired mobility, characteristics that associate to self-injury, sensory impairments, and importantly, impaired expressive communication. So these characteristics mean that this behaviour comes to be very adaptive. It solves the problems that people may have at that time. And finally, a broader environmental characteristic may be that people with a severe intellectual disability may be heard but not listened to. In other words, the other behaviours that are there are not effective in influencing the environment, but these behaviours are. So that shows us that at the broadest level, degree of intellectual disability is important. And at the top there, you see a figure of 4. That's an odds ratio, so you are 4 times more likely to show these behaviours if you have severe intellectual disability as opposed to a mild moderate. And I'll mention later on why these odds ratios or these risk ratios are important to us. So I've shown you that a broad characteristic such as severity of intellectual disability is important, but we need to go beyond that. That's how far we've come in the environmental model, but I want to open this up now to other important person variables, such as individual differences in motivation, unusually strong preference and unusually strong aversion, and show how these might interact with that environmental model to drive the development of challenging behaviour. One place we can do this very successfully is by looking at the difference in the level of difficult behaviour across syndromes. So what you can see in this slide, running left to right, is the probability or the percentage of people showing self-injury with heterogeneous cause of intellectual disability, mixed cause, and then Angelman syndrome, Cri-du-Chat, Cornelia-de-Lange, Fragile X, Prader-Willi, Lowe, and Smith-Magenis syndromes. And the figure you see there, 6.47, refers to the heightened risk, for example, of self-injury in Cornelia-de-Lange syndrome. We can do the same with physical aggression, and in this case, show a heightened probability of physical aggression in people with Angelman syndrome. People are about 3 times more likely to show aggression. Now, at first glance, this shows us that a purely environmental explanation is unlikely to be complete, because we would expect no variability across genetic disorders. The fact that we do means we must give an account that takes into account that genetic disorder and the environment. And in Angelman syndrome, we thought the cause of that might be related, the cause of the aggression might be related to facets of Angelman syndrome. So for those of you who haven't met people who have Angelman syndrome, one of the striking characteristics is an excessive drive for social contact, and much of the happy disposition that's often reported in children and adults comes from an association with pleasure from social contact. But this drive is very strong, and one facet of this drive is particularly interesting, is seeking out constantly eye contact, in complete contrast, for example, to Fragile X syndrome. So if you look at this photograph, I'd taken these photographs for our research team to remind them of the children they were working with. And this is Gemma Griffith working with a young woman with Angelman syndrome. And if I show you the photograph of another research worker working with the same girl, you'll see again this striving for eye contact. If I flip between them, you can see this child constantly seeking out the eye contact of the other person. And this is very, very important in that it shows a motivational difference, a stronger motivation to solicit eye contact than in other people with an intellectual disability. So when we come to try to understand aggression in people with this syndrome, we might predict that we would not see incidents of aggression when there is constant contact between an adult and the child. But if we lower the level of attention, then we might see aggression occurring. The reason for this is simple. The most common form of aggression in Angelman syndrome is actually hair pulling. We run an experiment this morning when you go for coffee. Stand behind the person who's in front of you and pull their hair. And I guarantee you will gain eye contact. That person will turn and give you eye contact. It works like a dream every time. So what we might see then, in this case condition B, the lower tension, we might see higher levels of aggression when there is low attention than when there is not. So we ran this experiment, 20 people with Angelman syndrome, 20 with Cri du Chat, 20 with Cornelia de Lange. And then we compare the probability that the aggression will be evoked in the Angelman syndrome group under condition B rather than condition A. And these are the results, and that confirms our hypothesis. Otherwise I wouldn't have done this very long story, but it shows you clearly that there is a significant difference in the environmental trigger for aggression in Angelman syndrome compared to other conditions. And if we do this at a questionnaire level, the QABF, we get a similar result. You can see over on the left, again, a significant difference between the Angelman's group and the Cornelia de Lange group, with the cause being seeking attention and attention maintenance of the aggression. So that's helped us build a model now, an individual causal model, where we can have the genetic disorder at the top, in this case, loss of information on chromosome 15, Q11, Q13, and the behavioural phenotype at the bottom with an intermediary factor, the cognitive endophenotype. When those two come together, that's when we see the aggression. So you need both the accentuated social motivation and you need the environmental trigger to produce the behaviour. Either of those on its own would not necessarily drive the behaviour. Attention and demands, for example. And when we do that, we, in one participant and then a second participant, we are unable to show any influence of these standard environmental manipulations on these children's self-injury. But if we manipulate an autism-specific motivational or autism-weighted motivational state, we can influence the behaviour. So if we interrupt a repetitive behaviour versus not, then we see a high level of self-injury. If we respond to repetitive questions, we don't see the behaviour. If we do not respond, we do see the behaviour. So these are examples of where a characteristic of autism, showing repetitive behaviour, a preference for showing that repetitive behaviour, needing an answer to repetitive questioning, if those are influenced in some way by the environment, so we see the behaviour. And if we look at the results for 10 children, just look at the bottom, we're able to show that when we use standard experimental functional analysis, i.e. assuming that motivation is the same in autism spectrum disorder as anybody else, we can't show an influence on the behaviour for none of the children. But if we use autism-weighted experimental functional analysis, we can show function for 6 out of 10 children. So that shows us, an important example here is sensory escape for 2 children. So in other words, the function of 2 children's behaviour was to escape an aversive sensory stimulus, so we could demonstrate this empirically. Importantly, what this shows us is that those child characteristics, strong preference and strong aversion, interact with the environment to drive the behaviour. But knowing something about those children, whether or not they have Angelman syndrome, autism spectrum disorder, guided us in how we might assess and ultimately intervene. If we pursue this theme of individual difference within the genetic disorders, we can also look at cognitive difference. For example, shifting attention, the capacity to shift attention, and also cognitive flexibility. And I'll just show you examples of this. First example comes from Prader-Willi syndrome. And so Prader-Willi syndrome is well known to be associated with impaired satiety for food. Again, an important motivational state, but more importantly, or to the parents certainly as importantly, it's also associated with a couple of repetitive behaviours that are very troublesome for parents. One is repetitive questioning, and the other is adherence to routine. And this is in the absence of the other kind of repetitive behaviours that you see on this slide that might be associated, for example, with Fragile X syndrome. In other words, these are specific behavioural, this is a specific behavioural profile for Prader-Willi syndrome, the repetitive questioning and adherence to routine. Another part of the behavioural phenotype is explosive temper outbursts that, again, parents report as being very troublesome. And this slide shows a poster by a young woman with Prader-Willi syndrome describing what happens to her when she experiences these temper outbursts. And you can see her describing a development of the temper, things becoming worse for her, and eventually an explosive outburst. And this is another part of the behavioural phenotype that people with Prader-Willi syndrome would report as troubling them. They're extremely remorseful and upset about these temper outbursts afterwards, and we believe is associated with the adherence to routine and the repetitive questioning. So as we start to build our model, you can see there the behavioural phenotype of adherence to routine, repetitive questions, and temper outbursts. And we're going to now try and run a pathway through there. So this is a complicated slide, but in the top left-hand corner, these are the results of an experiment conducted in a laboratory with children with Prader-Willi syndrome matched to children of typical development in terms of their overall ability. And when we run this experiment and we have a stimulus on the screen that asks children to focus on, for example, the colour of an object, and then switch and focus on the shape. When you ask children with Prader-Willi to switch their attention from colour to shape, they have a longer reaction time than typically developing children. Attention switching is more demanding on the cognitive resources of people with Prader-Willi syndrome. Interestingly, if you correlate the reaction time with repetitive questioning and adherence to routine, they are positively correlated. So the longer a child took to make that switch in the lab was associated with more repetitive questioning and greater adherence to routine. So in our model, we've now been able to locate the cognitive endophenotype of compromised attention switching that leads to adherence to routine, or is at least correlated with, and repetitive questioning. Now we needed to tie these to the temper outburst. So in some observational work, in the middle of this diagram, is the temper outburst. To the left of it, from our observations, are high probability behaviours that precede the temper outburst. And this is questioning and arguing. So now we have something of a sequence, a temporal sequence, showing questioning, arguing, preceding the temper outburst. And we were able to show this in 4 different children. Exactly the same sequence of usually a break in routine happening. Then we'd see what we call these precursor behaviours of arguing and questioning. The importance of precursor behaviours is that if we want to manipulate the environment now to see if we can evoke temper outbursts, we don't have to evoke the outburst itself. We can evoke these precursor behaviours, and so we're not causing the child too much distress. So now we've been able to pull together there different aspects of the behavioural phenotype, and we can take a look at what happens, in this case in a lab setting. So we have a difficult switching task and then 2 control tasks. And the point here is that we see these precursor behaviours in the laboratory when we ask the child to do a switching task. And so that shows us that this behaviour is associated to that particular cognitive demand. And on the right-hand side, if we introduce a game with unexpected change, and if we introduce an unexpected change in school, we get the same behaviours. So the point here is that when we look for this compromised attention shift, and we have a challenge, an environmental challenge to that, that's when we see repetitive questioning and temper outbursts. Just to complete the story, I haven't shown you yet that this is related to a specific CNS dysfunction or a particular abnormality in development of the brain. And here, the red area shows the activity that is indicative of the part of the brain that is being called on when you are doing attention switching, and this is in typical development. And you see that central area, I can just find this on the mouse. This area here is frontal parietal area, and in typically developing children, that's the area that's activated when involved in a switching task. For children with Prader-Willi syndrome, you will see that that area is not activated. So what this shows us at a neural level is that when we ask children with Prader-Willi syndrome to switch, the area of the brain that should be active is not, and interestingly there's more activity in the prefrontal cortex, suggesting that people are then drawing on a different cognitive resource. But what that tells us about the title of the talk, Take a Walk in My Shoes, is that for children with Prader-Willi syndrome, asking being able to switch is very different from asking any other child. And that's difficult to imagine that experience, if you see what I mean. So we're able then to trace the path all of the way, but also identify a particular cognitive impairment that appears important. A final example on cognitive difference is about cognitive flexibility, and I want to tie this into a lifetime developmental context. And I'll do this within Cornelia de Lange syndrome, which was really noted by Nyhan to be associated with self-injury, but as we are meeting more and more people with mild intellectual disability and Cornelia de Lange syndrome, we're starting to see some difficult behaviours emerge in the late teen years. And so this is the kind of information that would come to me via email from our charity, and it describes a young man of 18 who is showing increasing reluctance to go to college, and he's finding it increasingly difficult to cope with change. When we looked in detail at Cornelia de Lange syndrome, we find very, very high levels of selective mutism. In other words, speaking in one environment but not another, and this seems to emerge with age. So this is a description of a young man called Craig, and you'll see from the description that his parents are saying he's quieter than he used to be, and when he was a young child he was very sociable. And this was a very common description by the parents. They described this change over time, and Craig finding it more difficult to express himself with time. Again, we went to the lab and we tried to examine how much people with CDLS, Cornelia-de-Lange syndrome, spoke in comparison to, say, people with Down syndrome under the same conditions. And in each case, what we found is that people with Cornelia-de-Lange, even if we matched them perfectly for expressive language, they spoke less than people with Down syndrome under these various performance levels. The important thing for us is that in Cornelia-de-Lange syndrome, and this follows on very nicely from the previous presentation, it was deficits in executive function that predicted how much somebody spoke, and that was not the case in Down syndrome. So in other words, we were seeing these deficits in expressive executive function, predicting how much someone spoke, and flexibility in particular was severely compromised. And this became worse with age in this group in the teenage years. And what this shows us, really, is when we look at this kind of quote, we can see kind of almost into the future if we know the syndrome, because you can see there he will be 18, so we've got the late teens, the problems are getting worse, it captures our data on follow-up over time, things don't go exactly as he expects, the kind of attention switching problem we've seen in Prader-Willi, and the aggression, the result of too much of a demand on a particular cognitive system at a particular time in life for a person with a particular syndrome. The last thing I want to touch on is about pain and discomfort. And of course, this is not really a person by environment interaction, except there's an important sting in the tail, a twist at the end. So again, in Cornelia-de-Lange syndrome, we see high levels of self-injury. In the left-hand graph, if you have Cornelia-de-Lange syndrome, you're around 6 times more likely to self-injure than if you do not. And then if we look at the health conditions that people with Cornelia-de-Lange have, we see very, very high levels of gastrointestinal reflux. So people are experiencing pain in the gut, in the upper gut. And these are some of the behavioural indicators that parents have described to us as associated with reflux. And these are very important because they may be able to tell us that someone is experiencing pain when that person is unable to communicate that pain. And some of these might be highly specific to the identification of reflux. And indeed, if we look within people with Cornelia-de-Lange syndrome and compare those who show self-injury with those who do not, we see higher levels of these behaviours in those showing self-injury, suggesting there's an association between pain and self-injury in this group. And so the sort of model that we may have here is that the genes responsible for the development of the brain and the gut in Cornelia-de-Lange syndrome lead to malformation of the sphincter muscle at the top of the stomach. That leads to reflux, and that leads to pain, that leads to self-injury. And you'll note here that the environment is in some sense irrelevant. This behaviour will occur across all environments. An important clinical sign, interestingly, stability across any manipulation of the environment. But the environment isn't irrelevant. So a parent, we're running a study on signs of pain and challenging behaviour. This is an email from a parent to me saying, what's the point of doing this? Because when I go to the doctors and tell them my child is in pain, they do not listen to me. And that is the environmental interaction, if you like. A parent saying, my child's in pain, I know she's in pain, and this parent was found out to be absolutely right, that the acid reflux had already caused scarring in the esophagus. If I just show you this slide, just there you can see under unusually strong preference a number of different syndromes in which we've identified different motivational states: Smith-Magenis syndrome, Prader-Willi syndrome, Angelman syndrome, and monosomy 1p36 deletion, in which we see strong preference for attention, for example, and we've seen these cognitive differences in some other syndromes. Let me finish by talking about some of the broader implications. So I hope I convince you about the importance of etiology. What you may say to me is, but these are very rare syndromes. They are rare syndromes, but collectively, these are numerous. Approximately 10 million people in the world will have a genetic disorder associated with intellectual disability. There are any number of these microdeletion disorders and some of the other syndromes. The conditions are rare, but the numbers are large. These tell us about critical points of intervention at critical times. They tell us that the disciplines that we bring together to look at challenging behaviour must not have too tight boundaries, and it's important that we disseminate these findings to parents of children with these disorders to empower them to ask for the right services. Doing this top-down will probably not work. It does have to be grassroots up, a demand for the service rather than the command, if you like. And the importance in these rare disorders of collaboration. We build up clinical experience across countries, but we must start to share this experience when we're dealing with rare disorders. Final thing I want to say is about predicting the future and the case for early intervention. And we should be asking the question for challenging behaviour, what are the human and economic costs of not intervening? That's the right way to ask this question. We know that behaviour disorders do not appear overnight. They gradually increase from not being identified as a problem to being identified as a problem requiring management, intervention, additional resources and specialist placement. It is easier, one would expect, and I think the data will probably bear this out, to intervene earlier rather than later, specifically on challenging behaviour. I've shown you risk markers as I've gone through the talk, and these risk markers are important because we could see these in young children before the behaviour is developed. In other words, we can target early intervention by quantifying the risk a child has for showing those behaviours. I like the title of the conference, Learning from the Past and Shaping the Future. And I'll finish by saying there are certainly pitfalls and merits of syndrome identification. We must be careful how we use labels. A label about a personal characteristic is at sometimes important, our gender, our age, our heritage, is at sometimes important, at other times it's irrelevant. So we must be careful how we do that and avoid, for example, genetic determinism. When these behaviours occur, there's nothing we can do about them. That's incorrect, and I think I've shown you the evidence. Take a walk in my shoes. The example I would give you is that people with Prader-Willi syndrome have often been described in the literature as being obstinate and stubborn. The reference is that you are refusing to do something. You won't do something. Whereas more correctly, it's that somebody cannot do something. And we can only understand that when we put ourselves into the place of a person with Prader-Willi syndrome, trying to understand what it's like to switch attention. And I think this is a very good example of a failure of theory of mind, perhaps, of clinicians and researchers. In other words, not being able to put themselves in the position of someone with that syndrome. And finally, early intervention. The question I leave you with is, if not now, when? We will not be able to build the case if we have 20 years of self-injury. We don't want to take data on this in 20 years' time to see if it's worked. I feel the time is right now for targeted early intervention for challenging behaviour based on risk and based on the models that we have. I'll leave you with some advice from Reinhold Niebuhr that I found helpful. For the translators is, God grant me the serenity to accept the things I cannot change, courage to change the things I can, and the wisdom to know the difference. And I think that's very good advice for us who support people with these rare genetic disorders. Thanks very much, and thanks to our sponsors and to the team back home.